Hello and welcome to How to Build a dApp. This talk is going to be broken up into two main parts. First, we're going to give an introduction into what a dApp is, and then second, we're going to jump into a live coding demo showing you how to build a dApp from scratch. My name is Nader Dabit. I'm a developer relations engineer at Edge and Node. At Edge and Node, we create and support protocols and dApps in the DeFi and Web3 ecosystem. We also participate in the Graph community and ecosystem. The Graph is an indexing protocol for querying data from decentralized data sources like Ethereum and IPFS using GraphQL. Part of our ecosystem development includes supporting DeFi and Web3 projects, product development, investing in people and protocols, as well as dApps within the Graph ecosystem, and also active participation in different crypto networks. With that being said, let's talk about Web 2 and Web 3 and kind of what each of these things means. I think there's kind of an evolution between what we had in the past and what we're headed towards in the future. And a lot of people talk about these things in the sense of Web 1, Web 2, and Web 3. We're currently experiencing Web 2.0. Web 2.0 is the user-generated content, read-write interactive version of the web. Things like social media, where we have Facebook, Twitter, TikTok, and Instagram, where people can upload videos, they can make comments, they can communicate with each other. Also things like blogs, wikis, video sharing and hosting, as well as image sharing and hosting. But the next step is kind of what a lot of people are moving towards, as well as a lot of the work that we're moving towards here at Edge and Node, moving towards what is known as Web 3, which you could think of as kind of a decentralized version of what we have today, along with a few other benefits that we don't have today. Web 3.0 kind of has all of these different characteristics: secure self-publishing, secure communication, secure storage and sharing, secure money and contracts. It's decentralized, secure smart contracts, dependable, trustless, and robust infrastructure, and self-sovereign identity for all people, orgs, and programs. Now, a few of these characteristics are kind of part of what Web 2 is, whereas some of these are kind of only unique to Web 3. And the way that we get there is a lot different, though. When you think of Web 2, we're often relying on centralized infrastructure or hosting providers to deal with all of the important things that we need to have happen for our application to work, whereas Web 3 is more focused on peer-to-peer or decentralized infrastructure. So let's take a look at what decentralization means in the current world that we're in the Web 2 world. A couple of examples might be something like media. A long time ago, when people wanted to get information and they turned on the TV, the only way that they could kind of get that information was from a few main news sources. ABC, Fox, CBS, for example, might be the ones where you would kind of be getting all of your information. And if it wasn't coming from there, you may not be getting it from anywhere. Today, we can jump onto Twitter, though, and we can get our news directly from news sources. So we can go directly to the people on the ground. We can deal directly with reporters, things like that. So we're kind of removing that middle layer of whatever was there before that may or may not have been a good thing, right? A lot of times, these middle layers, especially when it comes to news, might be influencing the outcome of what the message is trying to be put across. You're also seeing decentralization in a lot of other domains. One of those is Airbnb, in the sense of before, if you wanted to get a hotel, you typically were going to go with one of these big hotel chains. But now Airbnb is a platform that allows kind of the decentralization of a hotel, or open up people's houses to let them stay there and things like that. You could think of YouTube as kind of a decentralized platform for people to create videos of themselves and kind of get their name out there in the entertainment sphere. So Web 3 you could think of in a similar sense as what we were talking about with those examples, but in Web 3 we're focused on the decentralization of web infrastructure. All of the traditional web infrastructure that we may have had in the past, how can we go about decentralizing that? So in essence, a lot of the things that we're talking about come down to getting rid of the middleman and allowing people to deal directly with other peers that are participating in some network or protocol. So let's take a look at the Web 3.0 infrastructure diagram that's given to us by the Web3 Foundation, which is pretty interesting. There's a lot going on here that we don't really need to kind of dive deep on today. But I think the layer 1 and the layer 2s are a lot of the things that you see a lot of innovation happening in the Web3 ecosystem. So layer 1s are going to be the actual blockchains themselves, things like Ethereum, Bitcoin, as well as protocols like IPFS that enable file storage and even website storage for static sites. And then you're seeing these second layers kind of built on top of these other layers that enable more of the rich web infrastructure that we're used to in the Web 2 world. And we're not building those directly on these bottom layers, but we're kind of building out these different layers that enable a lot of the things that we, again, are expecting out of our rich and performant web applications, but building them in a decentralized way. So let's talk about some of this core infrastructure. When you think of a typical web application that you might build with AWS or something like that, you typically have like this 80-20 rule of what is the functionality that we need versus what is going to maybe differentiate us from our competitors and kind of make us stand out. That core infrastructure typically revolves around authentication, data, and storage. And on the left hand, I kind of have these 5 things: compute, identity/authentication, data, storage, and web hosting. You can build out a lot of different applications just using those core building blocks. And the only thing that Web3 really adds to this as far as core infrastructure is concerned is this idea of smart contracts, which enables a lot of the concepts that we're kind of trying to get across in the Web3 ecosystem without kind of going into a lot of it. It's a lot of stuff that happens around self-governance and building into an application some way to govern what is going on without a third party that needs to be involved. All of this is programmed into the contract itself. So that's kind of a really, really quick overview since we don't have a ton of time for this talk. That's kind of what a dApp and what Web3 and decentralization kind of looks like today. Let's talk about how we might build one of these dApps and kind of what we would need to get started with it. So at a basic core level, some of the main things that you would probably want to work with to just get started are a client framework, an Ethereum or some blockchain development library, some Ethereum or blockchain client library, as well as a wallet that interacts with the blockchain. So in this talk, I'm going to be kind of talking about what I think is like a really modern take, a modern stack, based on what a lot of companies are using today. The client framework is going to be React. The Ethereum development environment is going to be Hardhat. The Ethereum client library is going to be ethers.js. And the wallet is going to be MetaMask. Now, you can build all this stuff from scratch like I'm going to do, which kind of, to me, helps me learn how all this stuff fits together. But you can also use a boilerplate. There's a couple of good ones out there, like Scaffold ETH, which will kind of roll out a decent starter project for you. And this is kind of this talk or this demo is kind of based on a blog post that I wrote recently called The Complete Guide to Full Stack Ethereum Development on dev.to. This blog post did really well. I think I made a little over 60,000 views at this point. A lot of positive feedback. So I figured why not kind of package this into a talk and show you how to build this in a very concise manner. So with that being said, let's go ahead and get started building our dApp. And to do so, I'm going to go ahead and escape and go into my terminal and start writing some code. In my terminal, I have a basic React project. And what I would like to do to kind of kick off this dApp is I'm going to go ahead and initialize a Hardhat development environment. So I'm just going to say npx Hardhat. And this will kind of build out and create my Ethereum development environment by walking us through a couple of steps. I can create a sample project. I can take the project root. I can accept the git ignore. And now I can go ahead and open this up in my text editor. And once we've initialized Hardhat, we should see that we have our project kind of set up with a couple of different new files and folders. Once Hardhat is initialized our Ethereum environment, we now have this Hardhat config. We have a folder for our smart contracts, which is going to be where we write our Solidity code. And we also have a scripts file that will allow us to deploy our contracts to the blockchain. So the next steps that we're going to do is we're going to go into our Hardhat configuration file, And we're going to go ahead and set up a really basic setting for what we're going to need. We're going to go ahead and bump this Solidity version up to 0.8.3. We're going to say that when we run a build, we want our smart contract artifacts to go in the src directory, because in React, we're going to be importing from here. And we're also going to set our chain ID to 1337, which is a hard hat configuration that we just need to do to kind of get up and running. The next thing that we're going to do is, now that we have hard hat installed, we can now go ahead and create our own local version of a blockchain network. So to do that, I'm going to go ahead and open up a couple of windows here, and I'm going to go ahead and say npx hard hat node. And this is going to go ahead and spin up a local version of a blockchain for us. It's going to go ahead and create a bunch of accounts, and each account is going to be given an account ID or an account address, as well as a private key. And the private key is what we're going to use to get our ETH. And in this case, we have 10,000 ETH for each account. The next thing that we're going to do is we're going to go in our contracts, and we're going to go ahead and update the name of this contract to be token. And token is going to be us minting our own tokens. So you've probably heard of cryptocurrencies and stuff like that. That's kind of what we're going to be doing. We're going to be creating a really basic cryptocurrency. So to do that, I'm going to go in token.sol, and let's go ahead and delete this code. I'm going to go ahead and paste in my smart contract. Pretty basic stuff here. We're going to walk through it. I'm setting the Solidity version and the license here. I actually don't think I even need that line there. I'm creating a contract called token. I'm giving this token a name of Nader Dabit token, a symbol of NDT. I'm setting the supply to 100,000. I'm setting a mapping, which is kind of like an object or a map in JavaScript that is named balances, that has a key of address, and the value is of type unsigned integer. In our constructor, we're going to be able to go ahead and mint some tokens, meaning that whoever deploys this contract can be considered as the treasury. And I, or whoever deploys this, is going to receive these 1 million tokens here by referencing the message.sender. Now, the message is a keyword in Solidity, meaning whoever is interacting with the smart contract or writing to it. So at the deployment, that's going to be the owner or the treasurer. But when someone wants to interact with it, it will also be available here as well as the message sender. So if I want to write to this contract to transfer some tokens, I can also access the message sender here. And we have a function that uses the message sender to transfer tokens to different people. So when I deploy this contract, I'll be given 1 million tokens. I can now transfer these tokens to someone by passing in their address here, as well as the amount. We do a quick check to make sure that I have that many tokens to send. If I do, then we'll continue on. We'll subtract the tokens from my account and put them in their account. We also have a basic function called balance of that just returns the balance of the person's address that we're passing in. So that's our smart contract. Pretty basic stuff. We wrote our own cryptocurrency in about 20 lines of code. If you want to write your own real cryptocurrency, you can actually do this fairly easily, but I wouldn't use this exact code. I would instead use an ERC20 token and extend your contract from that. You can really easily do that. There's a lot of examples out there, including my blog post. I kind of show how to do that. But for this talk, we're going to be kind of doing really basic stuff. So what I want to do is, now that I've created my smart contract, I want to go ahead and compile that. So to do that, I can run npx hardhat compile. npx hardhat compile is going to look and verify my smart contract is a good smart contract. And if it is, it's going to create an artifacts directory. And in this artifacts directory, it's going to give us something called an ABI, which is the application binary interface, which is what we can use on our client application to interact with this smart contract. So now that that's there, we know that's there, we want to deploy this. So how do we deploy this to this network that we have here? To do that, we're going to run a script that Hardhat created for us when we ran npx hardhat, and we're going to rename this script to deploy. And in deploy.js, we're going to be, let's go ahead and delete some of these comments. We're going to be basically taking a reference to the token contract here. So we're going to say const token, and we're going to say we want the token contract. And then we can say const token is wait token.deploy. We don't need to pass in any arguments. And then once that's deployed, we can say token deployed at token.address, and we can log out the address of the smart contract that we've deployed to. And we'll be off to the races. Now, how do we actually deploy this contract? The way that we're going to do that is we're going to go to our terminal, and we're going to go ahead and deploy this. So I'm going to go ahead and run npx run scripts /deploy.js, and we're going to say we want to deploy to the localhost network. And once this is deployed, we should see the actual deployment come through right here on this side of our screen here. So let's go ahead and try this out. All right, and once the app has been deployed, we should see a lot of output over here, including information like the contract address, transaction, as well as the address that sent the deployment. So now that we have that deployed, we should be able to go ahead and start interacting with it from our front end. But before we do that, let's go ahead and import this account into our actual browser wallet so we can start using the ETH that is available. And the way that we're going to do that is we're going to copy this private key, and we're going to go into our browser, and we can install an extension called MetaMask. And here you can go ahead and sign up for a free account, and you should be given a wallet. And since we have this node running, we can go ahead and jump to this localhost node, and I can go ahead and import an account. And to do that, I'm going to go ahead and click on import account. I'm going to paste in the private key here. Try that again. And here we should see that we have our ETH. So in this case, we have 9,999 left over because we deployed, which used some of our fake ETH. And this is, fake ETH for sure. And we're now available to start using that, in our app. So the last thing we want to do is we want to go ahead and wire up our front end application to start interacting with this. So I'm just going to actually copy a bunch of code over here. And we're going to go ahead and open up our app, and we're going to go into src/app.js, and we'll go ahead and paste in the code on our client side that we're going to need to be working with. And one of the things that we're going to be needing is our token address. So like, what is the address where we just deployed the smart contract? I can get that by going to my terminal and copying it here, going back in my browser and pasting it here. So this is a basic React app. We have a couple things going on. We have a couple of form fields that we're going to be keeping up with. So when the user types in the amount they'd like to send and the account they'd like to send it to, we want to store that in the state. We have a way to request their wallet. And then we have two functions that interact with our smart contracts. One of those gets the balance that they have left, and the other sends coins. So when I sign in, I can see how much I have left, and then I can send coins, and then I can check it to see how much I have left after sending my coins. And then all we have left in our app after that is a pretty basic form, and nothing really specific going on there to this stack. That's kind of some basic React stuff. So we want to go ahead and test this out. So to do so, I can go ahead and run npm start. And we'll go ahead and give this a shot. And while that's loading, I'll go ahead and open up my browser here. See if we can't go ahead and load up localhost 3000 and see what happens. So this is a very basic app. And as you can see here, we have a form that says get balance or send coins. So I'm going to go in my console and I'm going to go ahead and try this out. So I'm going to click get balance. And this is going to go ahead and prompt me to open up my MetaMask wallets and essentially authorize this. Connect my wallet, and now we see we have a balance of 1 million, which is exactly right because that's how much we deployed to ourselves. And now I want to send some to another person. So the way that I might do that is I'll go here and I'll go ahead and say create an account. I'll call this like test. I'll get the address. I'll jump back to my main account and I'll paste in that account ID. And I'm going to send them 100,000 tokens. And when I send the coins, it's going to go ahead and prompt me again. And here I can go ahead and authorize this request. And I now see that coins successfully sent to this address. I can now test that this went through by calling get balance again, seeing that my balance is now down to 900,000 after sending those to the other address. And I might even be able to go ahead and maybe sign into other account and kind of read those. But I think we're getting close to being finished on time. So that is my, quick demo to kind of show you how the stack works. I know that was a lot, but hopefully if you've never worked with this stuff, you maybe thought that was kind of interesting and maybe learned a little bit. So to wrap it up, I just wanted to say thank you so much for checking out this talk, checking out my demo. If you want to learn more, go to edgeandnode.com or go to dev.to/@Dabit3 or go check out my Twitter. Thank you for checking out my talk, and I hope you enjoy the rest of the event.